I have not.
Do you know what it's about?
No, I do not know what it's about.
Do you want to know what it's about?
Sure.
Okay, it's this girl named Gypsy, and her mom has like this disease. Oh, it's like Munch.
Trying to make like.
And
Munchausen?
yeah.
Okay.
Yeah.
Is it Munchausen by proxy?
Yeah.
Okay.
And so then she makes this girl pretend she's in a wheelchair, and she like shaves her head, and she
It's her daughter, though, right?
Yeah, it's her daughter, and then she like tells her that she had like cancer, and she tells her like she's like. Yeah. Like she said she tells her she was born in 1996, but like she was actually born in 1999, and then. Yeah.
91.
91. Yeah. And then
3 different like.
Yeah, she said she's allergic to sugar, but then and she made her get a feeding tube.
So it's like with this, it has to be 3.
Oh jeez.
To make up the consistency.
And then there's this TV show about it right now on Hulu. It's like coming out, and it's like really creepy.
Oh, that's cool.
Yeah.
It's actually pretty good.
It's really
I saw
good.
one episode and I want to watch the rest.
All right.
You should.
Okay.
But
All right.
I can't tell you what happens at the end because we like here.
Okay.
I know what happens.
Hi, Haley. Here you go. All right. So in GeoGebra, if you go copy a picture, you can actually paste it over into the GeoGebra graphics window. Whoa. All right. So Marshall mentioned the Like Nike logo. So that was why I did it. All right. So what your goal here is to get cubic splines to recreate the outline of a logo or a picture. You can pick a picture of yourself if you want to recreate your own face with cubic splines.
Oh God. That would be awful.
What if we did your face?
You could do my face if you really wanted to. Notice what it says in the very, very last line. More creativity gives more chances for extra credits.
Oh, so I'm not.
Wait, say that again?
Apple.
The more difficult it is.
I said more creativity gives more extra credits. So say you did the outlines of your cubic spline in GeoGebra, copied over into Microsoft Paint, and then filled it in with color. That would be.
Is it going to be like a closed thing?
Yeah, it could be. Yeah, well, it depends on what picture you take or what image you take. I would anticipate, yes, it'll be a closed thing.
All
right. Well, that's where I'm gonna talk about it. Yeah. All right. So let me show you what you will want to do with this. So over in GeoGebra here in the graphics menu, notice there's a whole bunch of things that you can construct. Over here you can construct points. Okay. And you can start plotting points on the logo. So say over here I can plot the points on the logo. Notice what it's doing on the left-hand side. It's creating points, right? So what I've done is I've gone around the outline of the logo, at least part of it, and created a bunch of points. From those points, I can pick out the X and the Y coordinates in the spreadsheet. So if I view the spreadsheet, your points, the points that I used were C through I, right? So C, D, E, F, G, H, I. That was the easiest way I could get them over into the spreadsheet. I couldn't figure any other way to do it except for typing it in and getting them in the spreadsheet. So I've got the points over there, but I still need to split the X from the Y coordinates because you need it separate when you do your cubic splines, right? Right? Well, that's actually not too bad to do over here because in B1, I'm going to type equals little x of A1. Little x of takes the X coordinate out of the point. And then I'm going to do the same thing in C, except I'm going to use little y of C1. Oops, not of C1. Little y of A1, because that was where the point was. And now I can copy this down. And now I've split the X and the Y coordinates. So you can copy that over to Excel and do your cubic spline stuff. Okay? Now, in these problems, you will need multiple cubic splines by using the different requirements that I have. You'll need multiple cubic splines depending on the picture, and let's see why. So your cubic splines, of course, are cubic functions. So if you've got something that's not a function, you're going to need more than one cubic spline to draw a top part and a bottom part, for example. I can't use the same points and then come back around this way because this part and this part's not a function, right? When we did our cubic splines, we went from left to right with the x-coordinates, correct? Okay? So you would need a cubic spline for here, you would need one for here. It turns back around here again, right? Turns around here. So this one, I think you would need 1, 2, 3, 4 at least, right? And anytime you get close to a cusp or get close to a vertical tangent, you're going to need to make a new spline. Because cusps and vertical tangents, those kinds of things, or not a function things, the cubic spline can't approximate. So you have to do them in 2 separate pieces. So, I mean, does that part make sense of what you need to do? It's not bad. You just have to trace around it with the points. Now, depending on how good of a picture you get, you might want to use more points. You might want to do some of the adjustment things that we talked about. We did curvature adjustment last time. We're going to talk about clamped today. And I want to see one of each of those 3 in your outputs. Okay. So we've got, remember, the original was natural cubic spline where we forced the curvature to be 0, right? We talked about curvature adjusted last time where you actually tell it what the curvature needs to be. And then clamped we're going to talk about today. Okay. But pick a logo. Obviously, the more complicated the logo, the more functions you're going to have. Not necessarily hard, just probably more time consuming. Okay. More extra credit, yes, exactly. Say it again.
Why would that make a difference? Isn't it just like in Excel, you just drag it down one more?
Well, what I mean is if you've got something that's really wavy, every time you get a turnaround, it's not a function, you have to use a different spline. Anytime you've got a derivative that doesn't exist, you'll have a different spline.
Yeah, but in Excel, you just have to drag it.
Well, I mean, you just have to do it as a separate function, right? I'm just saying you'll have to do it more times. Because also when you plot these points across, you want to make sure you do them in order. Make sure your x's are in order with your y's to make it work with your Excel spreadsheet correctly.
Like from left to right?
Yeah, from left to right, yeah. I mean, it's not hard to do, it's just, it'll be time consuming. No, I wasn't very careful where I put these, so you might want to zoom in a bit and make sure you put them right on the edges as close as you can. We want a good approximation on the outside. That's the idea.
And you can do like detailed pictures too. Is that, are you
you can do detailed pictures.
Stuff in the middle, like not just like curves.
Yeah, absolutely. You have stuff in the middle, all those things. Absolutely. Yeah.
Should we try to make our endpoints like means? Whatever it's like on this, so we try to make.
You should try to make a mean at the end. Okay. Yeah, so you should probably click when you're going to go from one to the next. You should probably try to click at the very end so that it ends out.
And then it'll let us use the same function. Right? Don't worry about that.
Yeah, because you're going to do them at a second point. Yeah. Yeah. In fact, what you might want to do is just when you do one piece of it, do it in one GeoGebra sheet. And then if you do another piece, just open up a complete new GeoGebra file and do it in there.
So what are we sending to you then?
Your GeoGebra files, the GeoGebra file where you put the logo in and put the points in, your Excel file where you do the computations, and then your one where you finished one where you plotted the spline. So you should have at least 3. You can do more if you've got them in separate files, but you should have at least 3 files that you send me.
And so if we do the multiple one, you just want us to send you like 3 or 4
Yeah. Yep.
And we're literally just sending them to you?
Yeah, just email it to me. Yeah. I mean, if you want to print it off to your final product, you can do that too. But like I said, if you want to do more creativity and color things in and copy it over to Paint or some other graphics editing thing, you can do that too.
So when you do it in separate, like each different separate like equation and a different sheet in GeoGebra, you could just copy the algebra part of it and then put it all in one.
Yeah, and put it all together, yeah. If you do your final function, like you just said, if you take your final function, copy that over to a new thing and put them all together, it shows all drawn all together. Yeah. Absolutely. And so then you can just send me that one file for the finished product. Now, I made it on a Wednesday in case you've got last minute questions on a Tuesday for me to answer. And we're also not going to have class that Thursday as a reward for making it through all this cubic spline crap.
Wait, this Thursday?
No, the Thursday the 18th.
Yeah.
We won't have class. So that's the day before Good Friday.
That's the day before my birthday.
Wait, do we have Good Friday?
So I'm-
Then we have Good Friday off.
Good
Yes.
Friday off. Right?
Wow, you're so nice.
You did. After going through what we went through with this stuff, you deserved it. You deserved it.
I hate cubic spline. I just thought everyone.
Thanks, Grace. We will let you know how you felt.
I should probably fix
I feel like you nearly cared.
No, I did care. Absolutely.
I feel like you cared.
All right. Are we all on the same page for what I expect? You can always ask questions.
I'm definitely.
Not as of right now.
I'm not in the mood to think about that.
All right. Okay. Yeah. So the to break it apart, is that what you're asking again?
So how do you back in the spreadsheet? He did,
Alright.
Yes. Yeah.
So like, for this one, you have 4 separate functions, but then you wanted to put it together to make.
So you should be able to make one function out of one spline, so then you can move in the algebra window where I did the sum of this. Yeah. So then it'd be one function with plot, and if you take that and take another one and make another function, it should plot at the same spot.
Okay.
So if you make one, or if you want to do them in separate sheets but copy the final thing, you can copy the function over to a new sheet, and then copy the second function over to the same sheet where you copy the first. So you should run the second. Yeah. All right. Yes, Mark.
Can you repeat how you got your beans, you guys?
Okay, so you know how I got these?
Yeah.
Okay, so I got these. So this is just equals little x of its function notation. So if I just open it back up again, you can see it there.
So parentheses.
Yeah, parentheses. So it's just like a function. It's just make sure you use little x and not big X. If you use big X, it doesn't know what big X is.
Okay.
So, unless you define big X to be little x, well, that's fine.
Yes.
Just what?
What happens if you try to zoom in on it?
Just hit it.
If I try to zoom in on the image,
Delete button.
does it not make it bigger?
Do not have the delete button. Backspace.
Good for me.
It just moves in the axis and not.
Oh, okay. Well, if you want to move, if you want to actually, another way to zoom the image, these points at the bottom, the A and the B, you can just click and drag it, and it'll make it bigger too. You can do it that way
No,
too.
watch this. And then when I try to like move this, I tried to
Oh, if you delete it, then it won't zoom in. Right? You need the A and B on there. Yep. Because it's the size of the picture is dependent upon where those A and B are. You can also rotate it too. If you click one and not the other and drag it around, you can rotate the picture too.
I don't know, so I don't know like what's going on.
Maybe you can.
What's going on?
Well, it said it's supposed to be 2 times C1.
Yeah, no.
But I don't know what's
Wait,
All right.
Dr. Joy, this doesn't like copy it right. Maybe it's on now. Yeah, it's like really like extended. And when I try to like, now, okay, but when I try to like adjust it, it's.
Because you're adjusting one, not the other. It's rotating it around.
Yeah, I know, it goes
Yeah.
all the way around.
Yeah.
Yeah.
Whoa, that was weird.
You can make a new Nike logo.
Yeah, look at that. Just do it, man.
Okay. Well, you can also do reflections too. So there's a way to do reflections in here. You can just reflect it across the side too. So you can go backwards, which might mean don't do it. So.
Yeah, it's
Oh, you could absolutely. All right. Are we okay?
Oh, I love this.
Oh.
Where did this come from?
This okay? We happy?
Well, we'll probably be asking.
Well, of course. I mean, I anticipate that.
Mainly Levi.
Mainly Levi. Levi always asks questions. Mainly both of who? Levi and Julia? Oh, gotcha. Okay.
No.
And Sydney.
Not Julia. Yeah. Just.
All right. So, back to what we were doing. Hopefully.
In the order.
All right. So
Are we maybe doing an example?
would you like me to do an example for curvature adjusted? That was what I was planning on doing.
Okay.
Oh, freaking.
That would be really super great.
No, not super great. All right.
Should I
So-
go for mine or just? Oh, sorry, Dr.
No, it's okay. I was just making sure you weren't talking to me. Okay. So let's do one that's curvature adjusted because I also want to do clamped today as well, so that you have all three of them, because I really do want you to do all three of them to play with this data and then turn in a file to me on Tuesday as homework. All right. So what? Like for points, yes.
That's what I'm thinking. So what do you want us to do? Turn in one.
I will talk about it after I'm done. Okay.
I'll never say it again.
Yeah, I'm never gonna say it again. All right. Let's just say I want to model the number of doubles for Robert Yount, just because.
Are you starting with a regular and then changing it to adjusted?
Wait, can I ask a really quick question?
Sure.
Okay. Wait, did we get like a grade for that first like big assignment?
I have to talk to the group that hasn't finished yet,
Oh, okay.
but you will get it. You will get a grade. Yes. Yes, there will be a grade. I just haven't got a final project yet.
Oh, okay.
Yeah. So, yep, there will be a grade. Like I said, my guess is once that's done, then everybody will get full credit. So that's my anticipation. Everybody else did stuff, so I saw what you did. So as long as it all works together, then we're all good. That's all I worry about. All right. Just for simplicity purposes, I'm going to change. Oh, hey, why is that in text mode here? You hate computers? Is that what I just heard?
Yeah.
Oh, that's weird. It's funny that you want to do a computer science major, huh?
Yeah, you got me on that one.
Yeah, I do that a lot. I don't know why it did that. It is recorded too. I don't know why it's doing that. Why are you not formatting these as numbers? Format cell as general. Why are you being a pain?
For sure.
All right, I'll just force it. I don't know why it's being goofy today. I'm just changing instead of being the years, I'm just changing it from 1 to whatever. All right. So this was a number of doubles, just cause. No, my gosh, Julia, you're so demanding. All right. But by the way, you have Tuesday off, next Tuesday off too, right? This is dividing day.
Heck yeah.
Yeah. What time did I sign up for my budget?
I don't remember. It's in Doodle.
Oh yeah, that's true.
Yeah. All right. That better, Julia? Can you see that okay?
Yeah.
Okay. All right. So let's say I want to pick out. I'll pick out the first and the last years. So 1 and 20. So maybe I'll go by fives. I'll do 1, 6, 11, 16, and 20. Okay. So just by the format that it's in. So 1 was that. 6 is that. 11 is that. Not sure this is any faster than copying and pasting would have been, but it is what it is. 20, 25. Yeah? All right, so then we do our deltas. So this is E2 minus E1. This one is F2 minus F1. And copy that down. All right, and then we have G1 plus, oops, sorry, 2G1 plus 2G2 and G2 and copy down. Oh, wait, copy. Yes.
What was your K again?
That's the 2G1 plus 2G2. That's the 2 delta 1 plus 2 delta 2. Yep.
It's not H1? Or
H1's your capital delta. Yeah, G1. Well, the way I have it set up is that way. Well, this is why I said if you have all your row reduction stuff already set up in a sheet, you don't have to retype it all every time. I don't have it set up, so I'm retyping it. So nothing about that was a different way to set this up. So when we do our row reduction, we'll also need the constants. So this constant, remember, is what? It's 3 times, what do we have? H2 over H1. Or, I'm sorry, H2 over G2 minus H1 over G1. And I forgot my H. Oh, stop it. I hit F2. Stop. You get to hear me yell in the video if you watch it again.
After go, I got my key spine order for my last one.
Oh, good. Nice.
I figured out what it was. I didn't have all of them fixed. I only had
Oh, you had the one fix?
Thought I'd throw that out there.
All right. That good? Did I do it right?
Yeah, I think so.
Okay. All right. So now when we do the row reduction, let's think about, I'm going to turn the light back on so I can write on the board. And I know this is not going to be in the, well, it'll be in the Excel sheet, it'll be on the recording, but obviously what I'm writing won't be on the Excel, on the video, but you'll just have to deal. All right. So when we did the curvature adjusted spline, remember we're adding the two equations, 2C1 equals V1 and 2Cn equals Vn, right? Instead of saying that the curvature is 0 at the first and last knots, we're specifying what the curvature needs to be at the first and last knots. Okay, so this is what we refer to as a curvature adjusted spline. All right. So this changes what your system of equations looks like. So your first row has a 2, 0, 0, 0, 0, 0, and a V1. You still have your delta 1, 2 delta 1 plus 2 delta 2, delta 2, a bunch of zeros. And then, I guess I didn't leave enough room there, did I? Your 3 times delta 2 over little delta 2, delta 1 over little delta 1. Of course, I'm making that behind the screen. All right. And then at the bottom, your last rows, you've got zeros all the way across until you've got delta n minus 2, 2 delta n minus 2 plus 2 delta n minus 1, delta n minus 1, and then your 3 times delta 2, not delta 2, delta n minus 1, little delta n minus 1, minus delta n minus 2 over little delta n minus 2. Right? And then your last, so those, the middle things don't change, right? The middle ones are what they are, okay? Because those are the equations we came up with for the interior knots. The only thing that's going to change in what we're doing here and what we're going to do here in a minute when we talk about clamped splines, which is a weird name, but that's what they call them. The only thing that changes is the first and the last equations, okay? So the last equation here, or the first and last row, I guess I should say. Your last row has a bunch of zeros up until the 2 and then a Vn. Okay? Now remember, when we talked about the natural cubic splines, Corbin here and messing with me and took my chalk. There's only 2 little pieces of chalk here.
Oh, we messed with Dr. Olson and
we
took
did,
the job.
yeah, it's under there.
Yeah.
It's
Behind
weird.
you.
Oh, that's over there.
If you really want it,
Yeah, we
there's
did
like
that
a whole box.
Okay.
I'm trying to.
You did that yesterday?
Yeah.
Is she not moving?
Well,
No,
we were doing like
We did group work.
Oh.
So she wrote one thing. on
It's
the board.
underneath it.
Oh, I see. Oh my
But
god.
she never even like asked about it.
Levi asked her.
I know, I
She
took
like
her.
I feel like she.
I just figured Corbin came in trying to mess with me. That'd be really funny if he did.
I mean, he was the one
Pull
who
it
put it
away.
there.
Yeah, that is true. It technically was.
It was Corbin? Okay. Alright. So, I just don't like writing with a smaller chalk. Anyway, so remember with the natural cubic splines, what's the first row? 1 and then a bunch of zeros, including this one, right? So remember in that case, we use the 1, you kill this delta 1, but nothing else gets changed because they're all zeros above it, right? Okay. When we do the row reduction in this case, though, when I use this 2 to kill this delta 1, my constant's going to change. Right? All right, so to kill this delta 1, what do I need to multiply this by? This is a 2.
I was talking about below.
That's a delta 1.
Yeah.
Yeah, negative delta 1 over 2 and add, right? Well, I gotta add. You do a negative times that and add, right? Because you remember your row operations are a constant multiple of one row and add it to the second and replace the second, right? Okay, so negative delta 1 over 2 times this and add it to that, right? That's going to do the same thing over here. So this constant here, you're going to replace with 3 times delta 2 over little delta 2 minus delta 1 over little delta 1 minus little delta 1 over 2. Okay, so that's how the first part of your row reduction gets affected. Your constant doesn't stay the same like it does when you do natural cubic splines. It changes by that subtracting off that constant. Yeah, Morgan.
So what about your V1?
Yeah, that's what I was
Oh. That should be a V1 on there.
Tip mark?
No. Stop trying to get tick marks all the time.
We only need 5 more.
Yeah.
What's it?
We definitely have 12 already, I'm pretty sure.
Why would it now?
Oh, we have 12? Oh, I missed
Well,
it.
Julia had one in the email the other day. She had to email him, remember?
And that should count as 5. If you put it on the internet.
I only take 5 for you here today. Well, that's true. If you put it on the internet is forever.
Yeah.
So it's an infinite amount.
There's an infinite number of tick marks. All right. Yes, that should be a V1, right? I could have had a V8. Anyway. All right. Not good? Oh my. Thank you, Nick. I appreciate it. See, Nick wants extra credit.
Okay.
I don't know. Sid will clap with you.
Oh, yeah. Where were we at? Oh, the math. Yeah. Like all the kids are like.
Well, Fibonacci clap.
Yeah, right.
1, 2, 1, 2, 3, 1, 2, 3, 4, 5.
Wow.
1, 2, 3,
You're
4, 5, 6, 7, 8.
You're kicked out of the math thing.
All right. We okay with that change for that one? Okay. So now the rest of your row reduction is exactly like it is for the forward part, right? Because again, we're going to make that one a 0. We'll use that one to kill the one below it. Use that one to kill the one below it. Use that one to kill the one below it, and so on down the line, right? And then this one doesn't ever get killed, and I don't have to take this one and add it to this row. Right? Nothing ever gets changed there. We agree with that? Grace, you have a question?
So like on Excel, would you pull this all the way down?
Yeah, you literally just change the first constant. That's all you do.
Okay, so you don't.
So over here we'll say equals the
I
K1.
can't see you.
Oh, what? You can't see me. I'm right here.
Is it one of Corbin's friends? I mean, Dr. Coach's.
why today is the last day of cubic splines. All right. We copy the K1 over, right? And we copy the L1 over. This is what we did before, right? We just copied the first row over. Okay? But in that last one, we're not going to copy just the constant over. We're going to do M1 minus, what is it? It was the delta, little delta 1, which is in, where? G1?
Yeah.
Divided by 2, and then multiplied by whatever you're going to do with your curvature adjustment. I would suggest, especially if you're trying to play with the functions and try to get it to match, I would put your curvature adjustment in some cell and use the cell reference rather than hard code the number in, because then you have to go in and edit the cell every time. Okay? I'm going to hard code it in because I didn't make it up to start with. But I would suggest putting it somewhere so that you can adjust the number easily and it'll adjust your entire row reduction accordingly. Okay? Yeah, great. Great.
Definitely forgot my question. Oh, I remember. Why are you not taking the first row? Like you just took the second column and...
Remember the first column is the one that it's going to get all killed. Those are all going to be zeros.
It's all zeros.
Yeah, they're all be zeros at the end. That's why I didn't bother.
They forget.
What's that?
I just went.
Actually, you know what? I lied. I am going to just refer to this. I'm going to put it in E7 just for whatever purpose. So over here in E7, I'll put a curvature of 2 in to start with. Just for argument's sake. And then E8, I'll put the other curvature in there. I'll make it -5, only because I'll come back and refer to it. All right, then down here, we have to use the 20 to kill the 5, right? So use the 20 to kill the 5, I've got to divide by the 20 and multiply by the 5 and negate it, right? And then but I've got to do the same thing to L1 to affect the K2, right? So this one, the next one down will be equals what? K2 minus J2 over O1, and then times the P1. O1's the one right above it.
And what's the setting up? What is the setting up?
Say it again.
What is the setting up?
This is just doing the row reduction. So you should already have this set up in your other. Yeah, it should already be set up. Literally, the only thing you have to change in yours, and if you're going to do it off your other one, if you go in and just put in this extra little edit, you can change these to zeros, and it'll do natural cubic spline. It'll put no curvature. Yeah, it's pretty works out pretty well. All right.
What's the formula you had in Q1?
Q1 is M1 minus G1 over 2.
I have different.
Cell reference, yeah.
Oh my gosh.
I'm sorry.
Well, it's your fault.
No, I just want to they need to see where you're pointing, and then I know where it is on.
Okay, this is your delta 1, right?
Uh-huh.
So it's this one
Uh-huh.
minus this over 2
Mm-hmm.
times that.
What's that too?
That's your curvature that you're adjusting. That's your V1.
That's just random number.
Yeah, just a random number. You're going to change it depending on how you're trying to fit your data.
Are we supposed to know how we're supposed to fit our data?
Well, if you plot the points, you'll see if it's... Because you're trying to do curvature adjusted. So if your points are going like this, you're concave down. Right? So you would make it a negative something. Right? If it were like this, it's concave up.
Genius.
Genius! I know!
And you'll see that.
Just by plotting your points.
Like in
Yeah.
And then if you don't like it.
You just adjust it. Yeah.
Oh, this actually feels really good.
Because all this is going to do is change your C's at the end, and then you can copy the C's over to GeoGebra and it'll change your splines. Yes.
So why do we only have to change the second C? Like, would that be the second C effect?
Not only when you're doing the row reduction. It doesn't affect it till the next step, which we're already doing. It's the same formulas. I haven't done that yet.
Oh.
Isn't absolute cell reference on E7?
You can make it an absolute cell reference. I'm not going to copy that cell down.
Oh, okay.
Yeah, it won't matter because I'm not going to copy that cell.
Okay.
All right, I am going to copy this cell. This, what's wrong? Are we checking to see if it's raining or not? This one is M2 minus, what was it again? It was J2 divided by O1. And I need to multiply that by the constant, which is in Q1. Now again, this should be set up in your spreadsheet. And again, if you want to go back and change your spreadsheet where you've got your row reduction set up, you only will need to change two formulas. The formulas of two cells, you can change it to doing that minus delta 1 over 2 times your V's. The V1 or the minus delta, here in a minute we'll do a different one. But you can change those two formulas and put zeros where I have the 2 and the negative 5. And that will be your natural cubic spline. When you change it, it's curvature adjusted. So P2 is
Yeah.
L2.
Just drag.
Oh, L2.
Yeah, I just dragged it down. Yeah. I just dragged it down.
I'm almost positive this is
All right, and then now I should be able to take this and drag it down.
You just drag it down once. P2.
Yeah.
What's wrong?
No, I know, but like,
P2 is just drag.
This is why I'm not in applied math position, by the way. We're learning. It's all that matters. That's the important part. That's what school's about. Learning's boring. What's it? Learning's boring? All right. We okay with this part? This, I mean, literally the only thing that changed from this, from your previous spreadsheet, was that minus piece that we put on Q1. Everything else should be exactly the same. Okay? All right. So now that negative 18.7233 is right here, right? That's where that is, right? Let's go ahead and do our adjustment for our constants here. So I need to make these all ones, all right? So I want to do, this is O1 divided by itself. And I don't want to change the column. Now, I don't want to change the, what are you doing? That function, F4. It is Corbin, I'm telling you.
This is the last day.
This is the last day of cubic splines. I didn't want to change the column when I copy this across. All I'm trying to do. There we go. I'm changing them to ones, right? Because remember when you do your reduced row echelon form, I want ones down the diagonal? Okay. All right, so right where I've got that circled, it used to be negative 18.72. Now it's negative 1.12. Right? That's the constant I need to adjust now. Okay? So in the other spreadsheet, what did we do? All we did was just copy this one over, didn't we? Okay? I don't want to just copy this one over in this case because I need to use this 2 now to kill this delta n minus 1, or what's right above it. Right? I need to use this number. I need to use this 2 to kill this number. I've got to use the 2 to kill the 0.24. That 0.24 is right here. Okay? So I've got to take my U3 and I need to subtract off what? Well, I've got to kill this number with the 2. So I've got to multiply by negative whatever that number is over 2 times that and add it to that. Right? So negative, what is that, T3 over 2, and multiply it by, what did I put that in, F7? Put the other one in E7? Or no, it's E8, isn't it? I don't want a tick mark. Remember we put those 2 numbers in there, the 2 and the negative 5?
Random number?
Random number, yep. That's where the E8 is. Yeah.
So when you say using the 2 to kill it, where is that 2 at?
That 2 is not on the screen. That 2 is right here. Because that row doesn't change. Yeah,
Where did your values come in the P and U columns? Like, where did those come from?
remember those, we're trying to change these numbers to 1s.
Uh-huh.
So we're dividing the P and the Q by the O.
Okay.
Oh, so why don't you use E7 for both of those?
Because the E7 is telling you what the curvature for the leftmost knot is. The E8 is telling you what the curvature for the rightmost knot is.
Go ahead. Is that what you're gonna ask?
No, well, and you just guessed, right?
Yeah, just make it up.
And so then you would recommend, like, if we're doing this, that we just keep guessing to the maximum.
Yeah, that's what we did all those errors for. You're trying to make those errors as small as possible.
So those are the
Or
2
by
that you
looking
used.
at it. What are you looking to?
The 2 that you used wasn't because the 2 is up there, right? That's when we divided by 2. Never mind. Yeah, the 2 and the negative 5 are random.
Well, the 2 and the negative 5 are random.
Okay,
Yeah.
got it.
No, I divided by the 2 because those are the
Because
2.
those are the,
Yeah.
okay.
Yeah.
Why are those 2?
You missed classes.
Yeah, you missed class
It's
last
just
time, Sarah.
It's
Seriously.
supposed to be, so.
Yeah.
It's just one of those, yeah, it just is.
Yeah. When you remember, we're trying to force the curvature. When you take the second derivative, the x squared term makes a 2 in front of it. The x cubed term will still have an x minus something in it, so it gets killed off when you plug the number in. So the only thing that's left is the 2c1 when you take the second derivative. That's what it's going to Yeah.
It's nothing.
All right. Now I need to use that constant at the bottom to kill the other 2. Right? Okay. So if we do that in this case, what do I have to do? Well, we've got to use this number, don't we? I got to use this number to kill, because I got to use this one to kill that one, and this one to use that one to kill that one. Right? So I've got to take negative T2 times U3 and add it to U2. So this will be U2 minus T2 times, what is it, W3? Is that where you have the adjusted constant?
So if we had like if our matrix thing was like 10 rows, then we would just do the bottom thing to like the bottom.
Yeah, it's just for the very, very bottom one, yeah. That's what I said. If you go back to your row reduction sheet that you set up and just change those 2 formulas, you only have to change 2 of them. You change this one up here when you do your row reduction now, and change the very top one. Don't change anything else. Literally just change that very top one. And change the very, very bottom one on the last one. You don't have to change anything else. And then again, you'll get a natural cubic spline if you change those 2 numbers and those cell references to 0. All right, so enter that, copy that up, maybe. Okay? Now, those are your C's, except for the first and last, right? Now, in the first and the last C's for natural cubic splines, what were those numbers for your first and your last C's? Zeros, right? Are they going to be zeros now? No. What are they going to be?
2 and
No.
2 and negative 5?
Nope.
Okay.
Not quite. The 2 and the negative 5 will be in there, though. is going to be divided by 2, right? Because I'd have to change this to a 1. So your first one will be V1 over 2. Your last one will be Vn over 2. Okay? So when you copy this over to GeoGebra, you're sad. If I go back over here, when I copy these over, maybe. Let's see, I'm going to put my x's, my y's, my deltas, my b's, so I'm going to put it here. And the f's, yeah. Try to keep it in the same relative spot. I left a hole at the top because I got to put in the first and the last. Okay. Now again, in this one, you might want to do the same kind of idea, just have a couple of spots where you've got your curvature adjusted one. Because remember, you're copying this over from Excel for your row reduction, but if you literally type in 2 and -5, you'll have to change it each time. I mean, it's personal preference. Whatever you want to do. I mean, you're going to have to retype them anyway, so I guess it really doesn't matter. It doesn't matter, do you want to type them off to the side and have them change, or do you want to type them top and bottom? It's up to you. You're going to have to change them anyway in GeoGebra. So this was, what? 2, and I have to do divided by 1, right? So I'll do, or divided by 2, which gives me 1, right? And then this one will be -5/2.
So.
Or again, you could put it over here. You could put your 2 and your -5 here. And just make this one A8 over 2. And make this one, for heaven's sake, A9 over 2. And then you can go back over and change them if you want to change them. It doesn't matter where you change them. You're going to have to retype them anyway. But this actually has the over 2 part put in there, so you don't worry about dividing in half each time. And then you would fill in the rest of your stuff with the way you've done it before. Nothing else would change. Literally nothing else would change. And so again, if you've got a GeoGebra sheet set up, you can go back and change your first and last would be the same thing and just change those to zeros if you want them as actual cubic form. No sighing. You okay, Grace?
No.
What's wrong? You fine? You lying? Okay. As long as we're all the same thing. What's going on?
You said we're only supposed to change, like, this is my original one.
Right.
Nothing changed. I'm
Yep.
only supposed to change this one and this one.
No.
Not that one.
This one and this one.
So why aren't these middle numbers the same as these?
They won't be. Remember when you're doing the row reduction, this first one kills all of those. Or not kills, but changes what you're going down. So when you're doing this one, it should adjust all of those. Then you come over here and you adjusted it some more, so then you have to do the adjustment here.
So it doesn't, they're not supposed to be the same.
No, gosh, no.
Okay, that's
No,
why.
no, they should not, they absolutely should not be the same.
I thought I got an equation wrong. I'm like, I don't want to go back and find it.
Yeah, Morgan.
So even though you're changing the formula for the second box for your reduction, when you copy it down,
You're only changing the number at the top box, so yeah, you're just copying it down. Or not copying it
still
down.
have like the same formula for all the boxes.
I didn't notice I didn't copy the top box down, right? I typed in the row reduction in the next box and copied it down. Because that constant adjustment only happens at this spot. So then I typed in the formula for the row reduction of the next spot and copied it down.
Did I copy it?
Okay. Other questions before we do the other type of spline? Because I really want to finish this today. I don't want to talk about cubic splines anymore. Okay.
I
Well,
like
good.
the Lagrange multipliers. Those are pretty good. They're not multipliers, are they?
The cardinal polynomials?
Yeah, those are pretty good.
Yes.
So when you copied and pasted to this F thing, was it just like, just all of these values?
Yep. Yeah, and I just shifted it down one because you have to put in your first C and last C.
So those
Yay.
are.
Yes?
Yes.
Yeah. Hey, cool. Yeah, you got it. Nice.
Alright, well,
Cool. All right.
let's just say.
So let's talk about clamped splines then. We need to set up the algebra.
say they're called?
Clamped. There's two other ones too, but we're only going to talk about clamps because, like I said, what's the model for today?
Last.
The last day on cubic splines. I can't make that more clear. I told Dr. Roth that today too. And Dr. Roth.
Pizza party, because we're ending it.
We should have a party because we're ending it. Oh, speaking of that, don't forget advising day there's pizza.
What time?
Noon.
Can I go even though
Absolutely.
officially anything yet?
Yep. You can, absolutely. You're allowed to come.
Yay.
Pepper and mushrooms?
What's that?
You said green pepper and mushrooms?
Would you like green pepper? Yeah, if you've got a specific pizza request, send it to me.
Oh, send it out.
Where are we getting it from?
Pizza.
Probably Pizza Hut. All right.
I think they will.
No, we had Pizza Hut last time. We had Sloan's a few times ago, but they're kind of unreliable for me. Or at Pizza Hut, you go over there and they have pizza.
You get cases.
All right. So, in clamp splines, instead of specifying what the curvature is going to be, we're going to specify what the slope is going to be at the first and the last nodes. So for a clamp spline, we specify S1 of x1 is some, I'll call it W, and Sn minus 1 at xn is some other W. I didn't want to use V's again because we already used V. Not the function values, the derivatives. I said we specify the slope. The slopes. Slopes.
Was that Sydney? What did you say?
So what do the clamp splines help us with that, like, you know, give them like the adjusted?
The curvature adjusted. So instead of trying to change what the bend of the function might look like close to that, you might try to say, okay, it's increasing, so I'll make the first derivative positive.
Oh, okay.
That kind of thing. And then maybe you'll use the first 2 or 3 points to get an estimate of what the slope might be over that whole interval and use that to start with that idea. Yeah.
Why is it S of n minus 1 and the x's are x?
Because remember, we have n points, but we only have n minus 1 splines. This is the leftmost x, this is the rightmost x. Yeah, right.
Can you do a clamp and a curvature one?
Together, not at the same time, no. Because remember, we only need the 2 extra equations because we have the 2 pieces of information that are missing. When we set up our system of equations, there's 2 pieces of information that are missing. So we only need 2 equations to fill it out. If we try to do both, we might get an inconsistent system. Which actually is the next topic we're going to talk about, is how do you solve inconsistent systems.
Can we not talk about anything else?
What's that? You can't handle it? Well, at the end of the semester, we're going to talk about Monte Carlo simulation.
Cubic splines really burn me out.
Yeah, they burn me out too.
I feel like I just can't do numerical
So
math.
we should eat pizza every day.
What's that? What'd you say?
That's what we should eat pizza every day.
You just eat pizza every day instead of having class?
Done, yeah.
Okay. All right, so
Okay.
if someone was to buy pizza every day, we can have pizza every day. I don't care.
We can all split.
Your day to buy.
All right, so our first cubic spline looks like that, right? Sure. We have a B1, a C1, a D1. All right, so what happens when we take the derivative?
The y1 goes with you got the b1 plus 2c1 so x x1 plus 3d1 x minus x1 squared.
Okay.
I can take the derivative.
Yay! All right, so that gives us our derivative. What happens when you plug in x1?
You get b1.
Yeah, you get b1, right? So when we plug in x1, we just get b1. That's supposed to be the w1, right? That's the value we're picking for the slope at the left knot, right? Now, remember we're trying to set up a system for the C's and figure out the B's and D's from that, right? That's not a system for the C's, that's a system about the B. But I know what B1's supposed to equal, don't we? What is B1 supposed to equal?
Delta 1, big delta 1 over little delta 1.
Minus little delta 1 over 3 times 2C1 plus C2.
Good. Okay. Remember right now, the original system that we're setting up is that we're trying to solve this for all the C's, correct? So let's get a C1 and a C2 on one side and everything else on the other. So let me multiply everything by 3, just to get this 3 out of here. I'm going to move, well, we'll move some stuff around. I'm going to take this whole chunk, move it to the left, the W1 to the right, and distribute the little delta 1. See if I can do that without making a mistake.
See?
All right, so if I've multiplied both sides by the 3 and distributed my delta 1 through and moved it to the left, I should get 2 delta 1 C1 plus a delta 1 C2. On the right, we should have 3 times capital delta 1 over little delta 1 minus little W1. Right? Everybody looks so happy about it.
Oh, wait, no.
Yeah, we're trying to get in terms of the C's, right? Okay. So now when we go back over to our big system, what changes? So where is this one going to go? It's going to go up here and replace this top row, right? Here we got so quiet all of a sudden. This is the equation that involves C1 and C2, isn't it? Okay. So remember, this is your C1 column, this is your C2 column, and so on down the line, right? So instead of having this top row here, what's going to be in the top row? Okay, 2 little delta 1 goes there. And delta 1 goes here. Right? All the rest are zeros because I don't have any other C's. What about the constant? I like the blah, 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 sure. Yes.
Where did you get the 2 little delta C1 plus? Like, where did that come from?
Multiply the delta 1 through here. I multiplied both sides by 3. Got rid of the 3. Distributed the delta 1 and just moved this to the left side. They're just here easy.
This is that loud.
Yeah? Okay. It's amazing what you see in here in your third room. All right, we okay with that? Okay, the middle chunk of equations don't change. Yeah, Grace.
So you subtracted the delta 1 over.
No, I took this chunk, moved it to the left.
Okay.
Move the W1.
I was missing a negative.
Yeah.
That's why I was.
Yep.
Okay, I got you.
Okay.
Sorry, I'm good. Cool.
Yeah? We good with that? All right. So now notice when you do your row reduction, you're going to have to get a little bit of a change, right? Because I've got to use the 2 delta 1 here. So you're going to have to make a little bit of adjustments with your row reductions in your Excel. Oh my gosh. I've got to use this 2 delta 1 to kill that delta 1, right? But that's not too bad because I just need to do a negative 1/2 times that, don't I? Now it will also change this one. So that first term here is going to get changed, right? And then you'll also have to change your constant.
Just so the top.
Well, yeah, because I have to use this to make that a 0. Whatever I do to this, I've got to do to that, and I've got to do to that.
But I mean, you don't copy it.
You don't copy it down, you're just going to change the first row.
So like if that was like a cell reference, if that was like A1, you'd be doing like negative A1 over 2 plus A2.
Yeah. And that's your actual ratio. The ratio that you're using is just negative 1/2, right? So I would do negative 1/2 of B2, negative 1/2 of B1 and add it to B2 to change that one.
Yeah.
And then similarly here. Okay. All right. All right. Let's figure out what the last row has to be. But again, basically, you just need to make that adjustment in your first row before you start your row reduction, right? Make sure you change that first row, right, before you go into the next one. All right, so let's do the last one. The last one said that, talked about the derivative at the last knot. What is the derivative of Sn minus 1? Or Sn minus 1 would be y sub n minus 1 plus b sub n minus 1 times x minus x sub n minus 1. Same thing for the c, and the squared, and the d, oh, for heaven's sake, and the cube. So what's going to happen for the derivative here? Same thing as last time, just with n minus 1s, right? So you'll have b sub n minus 1, 2 c sub n minus 1, x times, or x minus x sub n minus 1, and a 3d sub n minus 1, x times x minus x sub n minus 1 squared. Now, in the previous one, what did we plug in for x? The x1, right? Those last two terms canceled. What are we plugging in for x now? xn. So those last two terms cancel? No, of course they don't. Why would they? All right, so Sn minus 1 prime of xn should be what? The whole box of broken chalk. Corbin. We get b sub n minus 1, 2c sub n minus 1. What's a better name for x sub n minus x sub n minus 1? Delta sub n minus 1, right? Right? So we had 2cn minus 1 delta n minus 1, and then 3dn minus 1 delta n minus 1 squared. Remember, the only reason why we're going through all of this is to make the last equation. Okay? Just to get the algebra to work. All right. We have formulas for b and d, don't we? And I know that I want this to be w sub n. So this will be w sub n equals, you told b sub n minus 1 is what? Delta n minus 1 over little delta n minus 1 minus little delta n minus 1 over 3, 2cn minus 1 plus cn. Sid's no in her head, yes, but she could say no, she's doing this too. So. Yes. The C is what we want, so I'm not going to substitute anything for that. Bless you.
Bless you.
Your DNs are what?
Cn minus C n minus 1 over 3 delta n minus 1.
Okay. And then I'm going to delta n minus 1 squared hang out here in the end. Because it looks like math. Is that what
It's just, could you imagine taking this into Excel? It just doesn't look.
All right. With a broken shift key. All right. So, what's wrong?
I said it looks like hieroglyphics.
It kind of does a little bit. All right. So, let's simplify this a little bit. Notice that I've got C's in all of the terms on the right-hand side, except for this one. Okay, so let me move this to the left and multiply by 3 and get rid of that fraction. So 3 times W sub n minus capital delta n minus 1 over little delta n minus 1. That leaves us with what? I got rid of the 3 here, right? So I've got minus 2 delta n minus 1 Cn minus 1. And then I got a minus delta n minus 1 Cn. Just for that first part. Because I got rid of the 3, right? Okay. I also have to multiply everything else by 3 here. So this will be a plus 6 Cn minus 1 delta n minus 1. Right? All right, over here, this 3 would cancel with that 3. That delta n minus 1 would cancel with one of those. But I've also multiplied by a 3, right? So we've got plus 3 delta n minus 1 Cn minus 3 delta n minus 1 Cn minus 1. Good news is that I think all my numbers are going to work out right, so that's good. For what it should be at the end. All right, what's the coefficient on the Cn minus 1? Here's a Cn minus 1. Here's a Cn minus 1. Here's a Cn minus 1. What's the coefficient? Just delta n minus 1, right? So you got delta n minus 1, Cn minus 1. And then what's your coefficient on Cn? Yeah, if you're at 2 delta n minus 1 Cn. So notice the symmetry on our formula here, right? Notice in the upper left, we have a 2 delta 1 and a little delta 1, a 2 delta 1 and a delta 1. In the lower right, we're going to have a delta n minus 1 and a 2 delta n minus 1. Right? And then this constant will be 3 times Wn minus delta n minus 1 over little delta n minus 1. So here's the other adjustment you'll have to make in your row reduction. This one's a little bit more complicated, but not horrible. This is actually the fun stuff. This is actually linear algebra. The stuff with getting the technology to work that's a pain in the butt. What? I like algebra. I'm an algebraist. I should like algebra. Otherwise, I'm in the wrong freaking field. Yeah, Grace.
So on the other side of our matrix here,
Mm-hmm.
is it still equal, well, for our constants, is it still equal to 3 times big delta?
For these?
Yeah.
Yeah, the middle ones don't change. We're only just changing the top and the bottom ones.
Okay.
The ones in the middle, for the curvature adjusted and the clamped, the only thing that changes are the first and the last. That's it. The other parts of the system of the equation stay the same.
So now, before we didn't include the top row in our calculations.
Right.
But now we have to.
You have to worry about how those numbers change, yes. You don't have to actually put the numbers in, but you do need to worry about how they change before you start. Because from here down to here, the row reduction will be exactly the same. That won't change. You have to just these three numbers first. So that top line that you have in your matrix, you this one becomes a 0. So you have to adjust this number and this number. So you have to adjust two numbers. Because that last one becomes a 0. So when you do your row reduction, you've got to adjust that second entry and the very last entry. And then you've got some adjusting to go on at the end too. In the previous problems, this was a 0, wasn't it? In the previous problems, this one was a 0. It's not a 0 anymore. So you've got to figure out, when you get to this point, you've got to use this number to kill that one, which affects that one and that one. Right? So you've got to fix all of those and then work your way back up again. Okay. So you will have to worry more about the bottom row. The top row is not bad to fix. The bottom row requires some work. Okay. So I'll leave that to you to figure out. Okay, so you'll come ask me. Okay. But if you think about what it needs to be, it's not really that bad, right? Think about, use actual numbers at that point and see what you need to do for the numbers, and then see if you can extrapolate to what the cell references have to do. I promise, it's really not that bad if you think about it. It's not any worse than trying to get the technology to work. We do have class next Thursday. We have class the following Tuesday, and that's it before Easter. Yeah.
So I'm confused with, like we're changing the first. So like formula-wise, we have the same.
Yeah, the row. Well, when you do the row reduction, they change.
Yeah, I have no idea.
So because before we had zeros all the way across, so the things didn't change. Right? When we did the natural cubic splines, these numbers, these were all zeros. So literally all you were doing was taking the 1 and killing that, but it didn't change the rest of the row. And at the bottom, you had all zeros, a 1 and a 0. So again, you were just using that to kill that, and it didn't change anything else. That's why we didn't have to adjust anything. When we did the curvature adjusted, we still had a 0 here, so it didn't affect that, but it did affect this constant.
So when we put the formula in the formula.
Right.
It's not like something my coach has to do.
So, okay, that was kind of my question.
It's just, it's not really a just scrimmage or picking up basically. Like it's
Just trying to figure out where first make changes in like the Excel spreadsheet.
Okay, so the first place would be in when you start copying things over to do your row reduction, the first thing that has to change is that.
Okay.
This becomes exactly that. It's still 2 delta 1 plus 2 delta 2. You're going to minus delta 1 over 2.
Okay.
Because that's what we have to multiply this by. We have to multiply this by negative 1/2 and add.
So when you're putting this into your matrix, you do that.
Right. And then this one, this is going to get replaced with, well, it's still this, but it's going to be minus, I just give it a name, call it K1 just because. And this will be minus K1 divided by 2.
So after this class, will we ever use this? Like honestly, one. Will I need to know this stuff?
You're an actuary?
Yeah.
Then probably not. Now, will you have to know how to model things? Absolutely. So that's what we're doing, is doing some modeling with a very specific thing. We're doing some modeling. So will you have to do modeling in as an actuary? Absolutely, you'll have to do modeling. So you'll have to look at taking points and trying to fit trends and those kinds of things. You probably won't do it with a cubic spline, if you did, it would be something that was already pre-made, and you would just throw the data points in there and spit it back out at you.
Okay.
But one of the things that you do as an actuary is take a set of data and try to fit it to a probability distribution, because you're trying to make predictions about future events based on previous ones. So absolutely, will you have to look at data and try to fit it to a specific type of function? Absolutely. Just right now, we're just trying to force it to a cubic. Well, a bunch of cubics.
Gotcha.
So while you won't specifically do cubic splines, you will be doing curve fitting, essentially.
Okay.
And the stuff that we're going to do next, you absolutely. So the hell was that?
It's time to wake up.
The stuff that we're doing next with least squares, you absolutely will do as an actuary
Okay.
and as a scientist.
See ya.
See ya.
The things that we're doing next.
Yes, things that we're doing next, you absolutely will see again.
Okay, cool.
But we're going to do it from a linear algebra perspective
Okay.
because I mean that's phrase, so why wouldn't I do it from an algebra perspective?
This stuff doesn't seem that hard, but it's like,
This won't be that hard except for getting your spreadsheet set up to do this. Because you'll have to, I asked you to do one plant spline.
but I feel like, I don't know, on that baseball spline, I didn't like how it looked, but it was just the zoom and Greta like saved my life and made it look pretty, so I was like, oh, I got it.
So,
Yours look nice.
huh?
Yours look nice.
Yeah.
Yeah.
Yeah, that one's okay. So we're still not including the top row and the bottom row. We just need to have that like K1 calculation somewhere to like reference when we're replacing.
There's special cases, so
Because like if
Because
if we're replacing this with what it used to be minus this half of this value, we need this value somewhere then, right?
Yep, you'll need it somewhere, and you'll need it again when you go back up, because you also have to do the row reduction on that
So
one.
this would just be like another random like cell on the side that isn't a part of anything,
Right,
but okay.
Because notice when you go back up, you also have to make this a 0. Right?
Uh-huh.
This also has to become a 0, so this will get affected when you make this a 0. And this will become a 0 by whenever you made this a 1.
Okay, but we're making this one, or like this is what was in there, right?
Yeah.
We're replacing
Yeah.
this one with this.
Right, and then this will be divided out.
Mm-hmm.
So whenever this gets divided out, it will affect that constant.
Mm-hmm.
And then you'll use that constant multiplied by negative delta 1 when you add it back up here again.
Okay.
But whatever this you'll divide this out. This constant won't be this anymore, because remember, you're working your way down and then you work your way back up.
Mm-hmm.
So as you work your way back up, that will change.
Mm-hmm.
Whatever that constant is, you'll multiply by negative delta 1, because I've got to add that out. So you'll add it back into there. So yes, you will need to keep track of what that value is.
Bye, Dr. Joe.
Long story short, yes, you'll have to keep track of what that value is.
Okay. I'll